Welcome to Ask and Learn.
All right, guys, we're doing problem 36 of chapter 18 in Chemistry Central Science. So the atmosphere of Mars is 96% CO2 with pressure of 6 times 10 to negative third atm at the surface. Based on the measurements taken over a period of several years by the rover experimental monitoring system, the average daytime temperature at the REMS location on Mars is negative 5.7 degrees Celsius, while the average nighttime temperature is minus 79 degrees Celsius. Daily variation in temperature is much larger than what we experience on Earth. What factor plays the largest role in this wide temperature variation? The composition or the density of the atmosphere? It would be the composition of the atmosphere. So we can think of this equation. Q is equal to mc delta T. So let's focus specifically on the C. The C is our heat capacity. So when we have a substance, it will absorb heat to varying degrees. The ability of it to absorb that heat is going to be based on its heat capacity. So and we can think of this in terms of the atmosphere, because the atmosphere, it absorbs energy and causes to lose energy. So remember, heat capacity is the amount of energy needed to increase the increased temperature of 1 gram of a substance by 1 degree. So if you have a higher heat capacity, the higher your heat capacity, the higher you're going to the harder it is to raise the temperature of a specific substance. Conversely, if you have a lower heat capacity, it's a lot easier to raise the temperature. So the reason that at the range of temperatures you're seeing on Mars is larger than what we see on Earth has to do with how the I guess you could call this the average heat capacity of their atmosphere is very different than the average heat capacity of our atmosphere. It's the degree to which our atmosphere is going to absorb heat is going to be different than the degree the atmosphere of Mars is going to absorb and keep heat.